Welcome to episode 9 of the Robot Report podcast, which brings conversations with robotics innovators straight to you. My name is Steve Crow, editor of the Robot Report, joined as always by senior editor Eugene Demetri. Gino, what's up, my friend? We're almost at number 10.
I know. Pretty soon we're not going to be able to use Roman numerals anymore.
Unbelievable. New episodes of the podcast drop every Wednesday. We can be found on Apple Podcasts, Google Play, SoundCloud, Spotify, YouTube, and anywhere you get your podcasts. Please subscribe today and leave us a review. Another great show for you guys today. We have interviews with Kathy Walker. She's the executive director and founder of the Haas Eastern Kentucky Advanced Manufacturing Institute, also known as Ecammie. Tremendous story. They're doing tons of work to reskill the workforce of Eastern Kentucky and helping folks land advanced manufacturing jobs. We wrote about it on the Robot Report a couple of months ago. There's a link to that article in the show notes, but an amazing story that you don't want to miss. And also, Gene was right in his wheelhouse. He sat down with Robin Phillips, the head of Maxon Space Lab. Maxon Motors, they're playing a crucial role in the Perseverance Rover, which tomorrow, Gene, is set to launch from Mars.
I know. Talking about timely, I'm actually really excited about both of these segments this week because, there's been a lot of talk, obviously, about reshoring and reskilling and workforce development in connection with robotics. And Ecammie is a fantastic project that actually has results. And they've actually retrained former coal miners to be robotics technicians, which I think is really interesting. And then, as a space nut, I have to admit, I'm pretty excited to get a chance to talk to the people who actually worked on components that are going into not just the next Mars rover, but also a helicopter. And how cool is that?
I don't think I've ever heard you so excited. Is there? I think you need to. I think you need to launch your own space robotics podcast.
That would be awesome. I would not run out of things to say or people to talk to.
Yeah, awesome. And we'll also hit on some recent news as the never-ending story here, Gino. The Jibo social robot appears to officially be back. And Boston Dynamics, their Spot robots have landed another gig. But up first, as Gene mentioned, is our conversation with Kathy Walker from Ecammie. We hit on a lot of different points here, very important topics about reskilling the workforce of Eastern Kentucky and trying to even attract advanced manufacturing companies to relocate to the area. We talked with Kathy about scaling that program, positioning the U.S. to capitalize on robotics and automation and reshoring the demand for robotics engineers. And Ecammie is setting up a robotics lab at their headquarters in Paintsville, Kentucky. So a lot to get to. Here's our conversation with Kathy Walker. Enjoy. Kathy, thank you for being here. I know you're quite busy. How are things going?
Oh, they're going great, Steve. Thank you. Thank you for having me. Yeah, we're busy, but everything's going very well.
It's great to talk to you again. So, for those who haven't read the story on the Robot Report, just, quickly sort of give them the genesis about what Ecammie is and how you came up with the idea.
For the past several years, in particular the last decade, there's been a tremendous decline in mining jobs in the area. And as we talked about before, the mining industry has been the underpinning of this regional economy in Appalachia, specifically Eastern Kentucky. So we were left with thousands of highly skilled workers, jobless, without any opportunity. And not, the economy is mining based. So you were either a coal miner or worked in an industry supporting the mining industry. So we were forced to do something and diversify the economy and create jobs for our people.
I know that Ecammie's been going on for a little while now, but can you give some examples of what specific skills Ecammie students can learn? Because we're taking, obviously, people who are used to working in one industry and now serving as robotics technicians.
Yeah, so we focus primarily on CNC machining. So students learn to set up, program, and operate Haas CNC machines. And of course, the skills that they are learning are foundational, if you will. So they are easily transferred to other sectors of the advanced manufacturing industry. So included in our curriculum are items such as GD&T, converting to the metric system. We use CAD/CAM software. MasterCam is what we use at the center. Programming with G-code, machine setup, program and operation, and metrology. So with that, with the CNC program, the students earn national credentials from the National Institute of Metalworking Skills. And in addition to the technical skills, we are really heavy on the soft skills. Those are an integral part of the of the program. And those include subjects such as communication, the importance of a positive attitude, teamwork, punctuality, critical thinking, problem solving, and adaptability. The objective for us is to develop a well-rounded, balanced graduate. And amazingly, I receive as much feedback from employers about the soft skills as I do the technical skills. The soft skills we integrate them into the daily program, starting with, for example, punctuality. We're on military time, 15 minutes early or you're late. Where it's very regimented, extremely regimented. It's intense. It's not a cakewalk. If you attend to Ecammie, you will learn. You've got to be on your game or prepared to get on your game in short order in order to be successful.
Take just the robotics technicians out of it. How many folks have come through and graduated and been placed through the Ecammie program?
All of them.
Wow, that's great.
So, I mean, what do you attribute their success to? I mean, obviously you're a huge part of this, but I would think, the machinery and the hands-on learning is a big part of it, but it takes a tremendous amount of willpower for these individuals as well to have the attitude and the work ethic to go through something like this, right?
Yes, it does. The staff and I talk about frequently that the students come in one person and they leave somebody else. And it's incredibly uplifting and empowering to be able to walk up to one of those CNC 5-axis machines and make it work. And so we build a lot of confidence and self-esteem. We eat the elephant one bite at a time. This is an industry that has had very little exposure in this area, but we have tapped in absolutely to a gold mine of talent, and they are transitioning just exceptionally well. But like I said, it's military style. We have high expectations, and anyone that's been through the program will tell you all about it. They've got to get with it. And, this is bigger than Ecammie. It's about changing a stereotype of this area and putting our best foot forward.
And I've had the privilege of visiting Appalachia, and, for a long time, it's been sort of forgotten by the rest of the country. But as you said, there's so much talent, and that's a nationwide issue, right? It's how do we reskill people for the new technologies and new economies? Is there an example of a student that stands out to you, someone who, you think might be unlikely to become a robotics technician, but who went through the program and has come out with some sort of success?
Yes, we have. Just about everybody has a story. Really, I believe I'm going to write a book at some point. It's difficult to choose one. Early on, I'll talk about this because he's an employee of Ecammie right now. A fellow applied to the program. He's a 30-year coal miner in his early 50s, laid off suddenly. So he was way too young to retire, but coal mining was all he knew. He was completely hopeless and with absolutely no idea how he'd feed his family, pay his bills, and survive. So he took the initiative to enroll at Ecammie and learn about a completely foreign industry, CNC machining. Although it had been decades since he had cracked open a book, he was determined to learn to be a successful CNC machinist. So like many, he struggled at the beginning, but worked hard and was absolutely determined to figure it out. No doubt, there were 3 or 4 hours of homework at night at the beginning, and part of the just interject this at this point, that early in the curriculum, there is a lot of book work and online work. And then as we get into the program, it's all on the machines. So anyway, but it was intimidating for him, certainly, to look at one of those Haas CNC machines and imagine himself with the ability to program it, set it up, and operate it. But like many people from the area, his determination, work ethic, and his commitment ruled the day. He graduated among the top of his class, and he, in fact, did so well that Ecammie hired him to assist with instruction, as many of his displaced brothers from the mining industry who are now in the program are following in his footsteps, and he's helping them. And that's something else that we have found that has been very effective. This has been historically a bit of a closed culture, and we've trained our own instructors. And so it has been the way to go, is to train our own, to train others from the area. So it's a heartwarming story, and like I said, there are hundreds more just like it. So
you mentioned that there's, that culture is part of the issue, just as soft skills are part of the issue. What is sort of the challenge? Because on the one hand, there's the economic need, right? People need to find new jobs as the coal industry continues to contract. But at the same time, there's also the idea of inspiring people to be willing to make that leap of faith to a new career.
There's a saying here in the mountains that good news rides a fast horse. And once our first graduates were placed in amazing jobs, high-paying jobs, pretty cool jobs, word traveled very quickly. And we have lists and lists of people waiting to get in the program.
Those first placements were into Lockheed Martin, right? Is that what you're referencing?
They did. I came up with this idea, and of course it was just an idea. It was a concept, but it's always wise to validate that concept before you spend money. And we sent 3 test, if you will, students over to Vincennes University, which is the flagship Haas program. They did extremely well. They knocked it out of the park, and all 3 of them had several job offers. They were being begged to stay in Indiana by employers there, but they did want to come back to Kentucky. And all 3 of them were offered jobs with Lockheed Martin in special operations. So in a period of 15, 16 weeks, they went from mining coal to machining parts for Black Hawk helicopters and C-130s with security clearances.
I think I'm going to sign up. I think I'm going to sign up for Ecammie.
Yeah, even I'm not too old. I guess that's something to be glad of. But you mentioned, obviously these are great jobs to move into because people need to be able to support their families. Well, on the other side of that, what's the demand like? What's the shortage of robotics technicians? Because you hear a lot about the need for talent, but what are you seeing, or what have you heard?
Well, there's just an ever-increasing disparity in skill supply and demand. I mean, it's just remarkable. And in my opinion, for years, there's just been a growing disconnect between what we're teaching in the classroom and what employers need. And with the rapid pace of emerging technology, baby boomer retirement, and economic expansion, that gap is continuing to increase exponentially. Our initiative is about providing opportunity to the people of our region, but it's much bigger than that. It's about Kentucky, but it's about the United States of America.
Right.
As we continue to reshore these high-tech manufacturing jobs, we must figure out a way to provide manufacturers access to the highly skilled workers, and we must move quickly. We're behind. The solution to that requires a modernization of the workforce development system with all the stakeholders at the table, and it needs to be driven by industry. We need to have our policymakers there, in academia, and the educators. In my view, the current system is grossly outdated. It needs a complete overhaul if the U.S. intends to reap the benefits of automation and robotics. I'm hopeful that collaborative public-private partnerships like Ecammie can offer a new, innovative skills training model to contribute to the effort. In conjunction with a complete revamp of the training system, the industry needs to rebrand itself. Careers in manufacturing aren't what they used to be. They're cool, and we need to highlight the opportunities that it offers. These are rewarding, high-paying jobs. It's just incredible what some of these people are earning. And, though I think generally people are unaware of what advanced manufacturing of the 21st century is, and unaware of what it can provide, the kind of rewarding career that it can provide. So we need to work on changing the perception and rebrand that antiquated manufacturing stereotype. So there's plenty of people out there. I just don't think they're knowledgeable of the opportunities in this field.
That's a great point. I'm 35, and I don't think I know one person, whether I know them well or, maybe somebody I went to school with along the way and have lost touch with them. I don't think I know anybody that looks at the manufacturing industry as, sort of a sexy job, right? And I think that's maybe one of the main challenges is rebranding it. But I want to ask you, you just talked a little bit about, some of the things that have to come together in order to scale a program like Ecammie to other parts of the country. Are you having any of those discussions? I mean, has there been any? And I believe there's other centers somewhat like this in the country. But are you having any fruitful discussions about how to take this forward and make it even bigger and better?
I have, Steve. In fact, I've been contacted by other states interested in what we are doing. And, I must say that some of the initial conversations I've had with other people, they have some challenges that we do not. And I am very thankful. Kentucky is very blessed with leadership in place that supports these initiatives, certainly on a local level, a state level, and a national level. We have support. And I've said to people, what we are doing is not red, this is not blue, but it's red, white, and blue. It's amazing and refreshing, actually, how everyone has come together on this initiative, because we see the need and everyone's able to separate their differences, and we agree on this for the common good. So I have had the luxury, if you will, to have support from many administrations across the board. And Steve, as you mentioned, we'll soon be announcing another project that'll be quite transformative. I'm not quite ready to discuss that right now, but
you'll have to come back on.
Yes.
So Kathy, actually, you mentioned something that I thought was interesting, is that manufacturing has changed. And obviously, there's the reputation of both coal mining and manufacturing for being dirty, dull, and dangerous, which are ripe opportunities for automation and robotics. But at the same time, robotics is helping to transform industries so that, we've been in modern facilities and certainly for manufacturing where it's high tech and you can still get good paying jobs, but it's humans overseeing robots. The robots are actually creating a new kind of job than existed before. And there's such demand in manufacturing in the US in particular. So, you mentioned reshoring. Can you talk a little bit about, do you have that sense that what you're doing at Ecammie, that the rest of the country is ready for this? Are they aware of this? Because, from our point of view, this seems like a role model of the kind of thing that should be happening everywhere.
Yes, and I would agree. And we've had, we've had visitors actually from all over the globe come to Paintsville. Industry, the manufacturers are really taking note. For example, FedEx, they have been incredibly helpful to us. Aaron Prather has been here, and I collaborate with him. It's important that we are not just off on our own training something that we think is, for something that's needed, but that we know exactly what industry needs. And it's important, technology is advancing so rapidly that it's important that we stay ahead of the game there. And in order to do that, we must be joined. We must be holding the hands of industry. And that's what makes this so different. It's like I said earlier, it's 100% industry driven. And we have to be to stay relevant. I mean, otherwise, where the graduate's going to go to work? A lot of what's going on is just, like I said, it doesn't make any sense. To me, this is common sense. And yes, I believe, I am absolutely confident that if the millennials understood what this industry had to offer and how cool these jobs are, that they're tech savvy. And it's a fit. It's a hand in glove. We have to get the word out about these jobs. When people walk in Ecammie, it's spotless. And they always comment, you could do surgery on our floor. And that's today's manufacturing world. But people aren't aware of that. We have a lot of work to do. But I truly believe that once we get the word out, that people will be interested and they will come knocking at the door. So we have to have the raw talent, and the jobs are out there. But we have to do something, or we're going to constrain business growth in this country, and it's time. Opportunity is knocking at the door.
You said Ecammie is clean enough for folks to perform surgery on the floors there. Is that a preview of things to come? Is there a Ecammie Surgical Institute in the pipeline?
No, but people comment all the time. But I'll tell you, if you go to Stewart Haas Racing or Roush Yates Engines down in North Carolina, it's the same way. Spotless. Absolutely spotless.
Right. And that's certainly, in terms of quality of life for the workers, it's a big improvement. And again, people may not realize, we're in contact with the ARM Institute, the Advanced Robotics Manufacturing Institute out of Pittsburgh, which is a similar, public-private initiative. And we know, having talked with them and with you and with others, that every robotics company is hiring there's so much opportunity in manufacturing that it'll be interesting to see as this goes on, that people become aware, it is not dull, dirty, dangerous because the robots are doing that part. We're doing the best parts that humans can bring to the equation.
Oh, yes. And we're excited about adding robotics to the program. In fact, Ready Robotics will be here next Monday, and they'll begin teaching a 3-week program, which will become a part of our curriculum moving forward. And the course that they're going to teach will enable us to train students who already have the high-level CNC skills. They'll have the skills to automate their CNC machine using robotic automation. In just a short period of 3 weeks, they'll be able to operate a wide variety of robot brands and have the skills necessary to design and implement robotic automation on all the Haas CNC machines that we already have. So we're really excited about that, yes. And so many employers who come to visit us, they may have a robotic arm. By the way, they will be teaching on UR10, and we'll have 5 of those on site for the students to work on, to be trained on. And we do, as we speak, have a robotics laboratory underway at Ecammie that should be ready in probably about 60 days. So we're really, really thrilled about that. But back to the employers, many of them, say we couldn't find people. So we have, automation and robotics, but now we need the labor to operate them and maintain them. And it's it's interesting because a lot of our graduates already have touched many phases of the life cycle of a robot, from CNC machining parts for the production of the robots to assembly and testing, deployment to support and maintenance. Again, a lot of the skills that they're learning, the Ecammie, are universal, if you will. It enables them to transition very smoothly into some of these other affiliated fields. So,
Kathy, you mentioned the robot lab that sounds like you're in the process of setting up. What else is in there? And also, obviously, the big news for the year that affects everybody is the pandemic. And how has that affected your operations?
Okay, robotics lab, I'll answer that one first. We'll have UR and probably MIR robot. I'm not really sure yet. We're definitely going to have UR10s in there. We will be teaching those in conjunction with the CNC machining, to machine tend. And so that a lot of that is still under development. Ready Robotics is a partner of ours. I think with their operating system, that's going to be important moving forward to allow all the different brands of robots to speak to each other, and our people will know how to make that happen. We're excited about that right now. As far as COVID, our program was disrupted for about 8 weeks this spring. And when we resumed instruction, about a month later, we had that class graduated. That was my youth class. They had been with me 9 months. And despite the disruption because of the virus, every one of them are employed. I think this underscores a sense of urgency regarding the skilled labor situation as companies struggle to address now business continuity planning. There's no doubt that the proactive manufacturers who've integrated technologies are in the driver's seat, and I believe will profit tremendously from the early investment. And those in reactive mode must move pretty swiftly in order to stay relevant. Everything's strong. The jobs are out there. We continue to be optimistic about the future.
You should be. This is tremendous. And Kathy, one thing I want to ask you before you go, we'd sort of be remiss, I think, if we didn't ask you this question. We've talked a lot about reskilling the coal miners during this conversation, and you have quite the experience in the coal mining business yourself. Can you just quickly sort of summarize some of the work that you've done in coal mining as well?
I was primarily in the sales side, some operations. So I'm out of the industry in that department. And then I have been in the financial world as well. Started a couple of community banks around the country, and I sit on several boards. And so this has been new to me as well. I very limited knowledge of advanced manufacturing, but I rolled up my sleeves and got to know some about it. And it's really, really exciting. And I see a really, really bright future for our country, certainly for Kentucky. The astute businesses will think about making Kentucky a home, hopefully Eastern Kentucky. A lot of people from this area are generational. Their families have been here. They might live on the family farm, and they would like to stay here. So ultimately, that's the overarching goal of this initiative, is to attract industry to East Kentucky to provide opportunity at home for these people. So we've been having a lot of visitors, and I feel confident that will happen in the short run.
So this is a quote from one of the gentlemen that we profiled in our take on what you and Ecammie are doing. His name is Matt Neese. He said, "This is a dream come true. Ecammie gave me a whole new world, a career, and a future." That's just, that's what it's all about. So hopefully you've you have some time to sort of, I know you're still building this thing, but you've had some time to sort of reflect on just how important this is for these people, because I don't know, that's a perfect summary of what you're trying to do is you're giving them hope and a future. It's tremendous.
Well, thank you very much. And that's what we're doing. We're changing lives, and we're changing the trajectory of East Kentucky. Matt is a perfect example. He has just been amazing. He was an underground miner. He, like many, he never knew this was out there. Again, back to that awareness in advanced manufacturing, had no idea that this was out there, but never dreamed he'd have the opportunity to participate. And that applies to just about everyone who's been through the program.
Well, you've also opened my eyes up too as well about, coal miners and just in general what they're capable of. So, thank you for doing that. And I'm sure others are in the same boat as me as well. But Kathy Walker, founder and director of the Haas Eastern Kentucky Advanced Manufacturing Institute, thank you so much for joining us. And I know you have some news coming down the pipeline, so we'll talk again real soon.
Okay. Thank you so much, gentlemen.
Thanks again to Kathy Walker for joining us. We're going to switch gears here, Gino, and hit on some news headlines pretty quick. We actually broke the news back in March that a company called NTT Disruption, which is a subsidiary of NTT Inc., which is a massive global company, acquired Jibo's IP assets middle of March, I believe, of this year. And just late last week, NTT launched a new website for Jibo to talk about the future direction of the product. And as we said off the top, it's sort of the never-ending story with this, I think it was on, what was it, like the 2018 cover of Time magazine as one of the inventions of the year.
Yeah.
Then with all the struggles that they went to. And so here's the mission statement, basically, from the new Jibo website. It says, quote, "From hospitals to homes, elementary school classrooms to universities, Jibo will provide people around the world with much needed care, support, and companionship." I mean, just what are your thoughts on NTT trying to relaunch this product?
Well, I definitely wish them luck. The social robot space has been a really tough one, and we've covered it, the highs and the lows, right? When they would unveil something like Jibo at CES a couple of years ago, we covered it. And then when the company failed sometime later, we also covered that, and we helped break the news on those things. It's been interesting that at one point it looked like Jibo and other robots like it were being overtaken by Google Home and Amazon Echo or Alexa, these smart speakers, because it was still a tabletop device. It wasn't really mobile. It could move its head around and make cute expressions. But the real challenge was developing that level of interactivity, real-time natural conversation with users that's more than just Alexa do this or Google do that. And so I think in the years in between then and now, there is two things have happened. One, obviously AI has continued to improve, and two, there's the fact that all of us are stuck in our homes, and so they're taking another whack at it. And I think if they're careful and they have the right combination of technologies and ultimately applications, then they might finally be successful.
Yeah, and the company's actually Jibo, I guess no longer really a company, but NTT and Jibo worked together a couple of years ago on a application for kids, basically called Be a Maker, right? Where I think they use Scratch programming, one of those open source drag and drop block programming methods, where to try to teach these kids how to code. And maybe that's an approach, but I think a lot of this still depends on the price, right? I mean, that was one of the big hurdles for Jibo to overcome years ago was the pricing. I think it was like $900 for one of these things, which is just crazy. But NTT again is a global company. They're a massive company, so
that helps. That helps.
Yeah, that's certainly.
Deep pockets, you need that because we've covered social robots recently on the Robot Report, like Roy V and LEQ, and they're all pitching at slightly different audiences, where it's engagement with older people or education, but the cost pressure is tremendous. Who's going to spend more than they would on a smartphone for capability that has to surpass that, right? And that's really the challenge, is that everyone has devices. Even kids have devices, and they're walking around with them, or they're huddled in their beds under their covers with them. You've got to develop some sort of device that, not only does it maybe help them to learn how to do something or keep them connected to the outside world, but it has to do it in a way that's better than a handheld.
Right. So, we'll see what happens. We've reached out to NTT Disruption, and they have responded. So we're trying to get them on the podcast just to sort of unpack this story a little bit more, to learn, what are their thoughts about the future for the product, because it is a little, to me, still concerning. They still mention a lot of different ways or types of interactions that can be done with this robot, and it just doesn't. On the surface, it doesn't feel like they're still targeting a niche market enough for me. And, they still have this 3-axis motor system in there. And again, who knows how they've tweaked that. But, I had sources that told me that was a significant portion of Jibo's cost,
Right.
a couple of years ago. And again, how much value does that 3-axis motor system actually provide with, as far as interaction goes between the human and the robot. So we'll see what happens, but hopefully they'll come on the podcast and sort of tell us their vision, because again, I have another source that keeps telling me, they don't seem to be very focused on scaling this, outside of sort of their own internal consulting gigs. Right. So we'll see what happens, but hopefully we get them on the podcast soon. And another headline, Gene, that we got to hit on quick: Boston Dynamics back in the news. A new pilot program that they're running with Ford, where 2 Spot robots will be surveying a Ford plant in Michigan. Basically, updating the CAD file of these plants seems to be something that doesn't happen very often, and when it does, it's quite expensive. Ford said that the old method of surveying their plants costs about $300,000 and could take up to 2 weeks to do for just one plant. So they have a couple of human employees walking around with a tripod,
Right.
and they would have to, go to multiple locations, stand there for 5 minutes at each time, waiting for the scanner to come up. And that's baffling to me that it costs this much money. I mean, what do I know about surveying?
Imagine, you're doing repairs on your house, right? And they always say measure twice, cut once. And imagine multiplying that by the square footage of an automotive factory,
they're huge.
Right?
It's
They're
huge. They're huge plants, but $300,000. That just seems crazy.
If you've seen surveyors and LiDAR equipment and other types of scanning equipment are not cheap. So I think they're factoring in man hours of labor that are involved in the cost of that. And, they have to reset up that tripod a dozen times. Takes hours, where those people could be doing something that's perhaps more interesting to them, like looking at the results. And then second, if a robot can do it autonomously or semi-autonomously, so much the better. And I definitely want to give credit, because for a long time, Boston Dynamics had these cute videos on YouTube of their robots walking around or jumping or doing something cool. But now, to really demonstrate some use cases, I think that's what they have to do to be successful commercially. And I think it's a very interesting development. I'll be curious as to what comes out of that.
Yeah, so we have a link to our article and a video in our show notes as well. So for the time being, there's a couple robot handlers at that Ford plant. They're actually Ford employees, but the hope is to eventually be able to teleoperate the Spot robots from, somewhere else around the country. And, if all goes well, they'll roll out potentially other Spot robots to other facilities, Ford facilities around the country. They're leasing the robots for now. If you were to buy the Spot up front, it's about $75,000. So they are leasing it for now. But another thing that I thought was quite interesting, which to me kind of makes this application somewhat on the, iffy, is, the battery life for Spot is about 2 hours. If the robot needs to recharge, or if they're trying to conserve battery life, Ford actually has an autonomous mobile robot, an AMR, that can also chip in and do some of the scanning of the facility. So they're coming at this from multiple different angles.
Well, and I think the automakers are smart, because they're used to working with a lot of different pieces of automation. So I can easily see a day in the not too distant future where you've got a legged robot walking up and down stairs and surveying certain areas, a wheeled robot rolling through with obviously greater endurance, and then maybe launching a drone periodically to get into certain areas or to get a higher coverage. And so we're not too far off from the surveyor sitting in their office, gathering all this data as multiple robots of multiple kinds get the right data that they need to do their job. And again, I think that's a very exciting prospect, but I'm sure there's a lot of lessons that they have to find out on the way.
Yeah, and just a little preview of something potentially, some content coming down the pipeline for Gene and I is, we're actually getting a chance later this week to teleoperate a Spot robot out in San Francisco. So Gene and I are located in the Boston area, and we're going to be hopefully teleoperating a Spot robot all the way across the country. So, keep your fingers crossed, Gino, that this all comes together and goes smoothly.
I like long walks on the beach with a robot.
Yeah. So when that comes together, we'll share it with you folks. And to stay updated on all of the latest robotics news, make sure you check out our network of websites, the Robot Report, Robotics Business Review, and Collaborative Robotics Trends. Up next is Gene's conversation with Robin Phillips. He's the head of Maxon Space Lab, which again has been involved in the Perseverance Rover project. Perseverance is set to launch Thursday out of Cape Canaveral for, what is this, a 2.7, almost $3 billion mission to Mars, carrying with it some pretty sophisticated instruments to search for signs of ancient life on Mars and to drill core samples that they'll eventually bring back to Earth. Gino, this hopes to become NASA's 9th mission, I believe, to land on Mars.
Yeah.
Since the 1970s.
Yeah, I've been to Cape Canaveral, and again, if you're a science nerd or if you are interested in robotics or space exploration, it is, one of the most important places in the world to visit. But it's even more interesting to get inside the robots that are going to be sent. And what was interesting in my conversation with Robin is that I learned not only do they have to design these motors and components to be rugged for Mars, but they have to get there in one piece and they have to function for a long time. You can't just send a repairman out, not yet anyway, to fix things. And so you're dealing with really strict tolerances, and they've made some advances along the way, even in the last 20, 30 years, even within the past 5 years. And so I think our listeners will be excited to hear something that is about to go up into space.
Yeah, and I know he did mention he was a little concerned about really COVID-19, right? And
right.
How that could potentially impact the launch and making sure the folks working down at Cape Canaveral remain healthy. So, let's keep our fingers crossed that everything goes off smoothly tomorrow. So here's Gene's conversation with Robin Phillips. Enjoy.
I know that Maxon is going to be contributing motors or has contributed motors to an arm on the Mars rover. Can you talk a little bit about the development process involved with that? Because again, it's very different than for terrestrial applications where if something goes wrong, well, you can send someone to fix it or troubleshoot it. How do you, one, prepare for these conditions, and then what's the advantage that you're bringing to something that presumably has to run for many years far from home?
The arm that we're talking about here is not the big science arm that's on the front of the rover. That's just a copy of what was built for Curiosity, or not quite a copy, but a similar version of it. But after the big science arm collects the samples that Mars 2020 or Perseverance is going to be analyzing, it transfers those inside to what you could consider to be an internal laboratory. And to move those samples around within the internal laboratory, sampling and caching mechanism is its full name. There's a smaller arm which then holds these various samples, and the arm has a shoulder and elbow joints that's powered by our motors, and then the gripper on the end, or the end effector, which actually holds the samples, also has a motor from us. So given that the whole purpose of the rover is to drive around, analyze interesting science sites, collect samples of the most interesting things they find, package those samples up, and then deposit them for collection and later return to Earth, that motor is particularly the one on the end of the arm that holds every sample that it collects. Is absolutely critical to the functioning of this $2 billion mission. So you can imagine the amount of pressure that brings onto us to make sure that the motor that we deliver really does work, and that its chance of failure is as close to zero as we can possibly make it. And the answer as to how do we go about developing something like that is we receive specifications from our customer, so JPL in this case. Then we look at what we've done in previous projects that gives us an idea of what kind of direction we want to go with the motor that we're going to offer. We then laboriously go through with JPL experts and our internal experts, analyzing the design before we cut any metal, trying to, on a theoretical basis, get the design as high a chance of working correctly as we can. Then we build what we would call engineering models, and we do tests on those. Maxon has an extensive array of test facilities. So we would do vibration tests, we would do shock tests. We'll put them in temperature chambers where we cool them down to the same temperature as the Martian night at minus 130 degrees C. We'll heat them up to the daytime temperature, maybe plus 20. Then we'll run the motors at those at the high temperature and let it heat itself up some more. And then we'll repeat these cycles hundreds of times. And of course, the first versions don't work because there's always something we haven't thought of.
Right.
So then you do another repeat, you repeat the tests, and eventually say, now we've got the right thing. So then you build what we call a qualification unit. So that's where we formally track exactly how we built it, what parts went into it. We do a formal qualification, which means you're documenting everything that you're testing, and you're trying to simulate exactly all the conditions that the motor will see in its lifetime. So you'd start off by running some cycles of the motor operating just in the atmosphere. That represents JPL installing it and doing their ground tests. Then you'll shake it and shock it. That represents the rocket launch. Then you'll do a little bit of time in vacuum to show that the travel to Mars is okay. Then you'll do several hundred cycles of day-night temperature simulation to show that the stresses that the temperature changes don't cause anything to fall apart. And then you'll do a lifetime test with a duty cycle that's defined by JPL and represents the operation of the motor. And then if you get to the end of that lifetime, then you know you've got a design that works. And then for your flight models, all you need to do is make sure you build it exactly the same way as you built the qualification unit. That's easier to say than it is to actually do. But when you've done that, then you can have a pretty high level of confidence that your product's going to work.
And so, that is as grueling an engineering project as any I can think of, certainly here on Earth. Now, did you start with a base model of an existing maxon motor, or was this all designed from the ground up?
No, we hardly ever do brand new designs. So Maxon's philosophy in general is we have what we call our catalog motors. So there's a big, thick print catalog or the online version that has a whole bunch of what you might call baseline motors. So that's the starting point for any customer-specific version that we do. And that applies as much to motors that go into sewing machine factories as it does to space motors. We start with our catalog baseline. In fact, only something like 10% of people order directly from the catalog. 90% of our business is about doing modifications. Sometimes those modifications are pretty small, it's just a longer shaft or different cabling or something like that. And in this case, we move a long way from what it looks like in the catalog to get to something that's suitable for operation on Mars. But the core motor, the winding, the real insides of the motor, the insides of the gearbox, they're still the same tooth shape and the same rotor geometry as we would have in the catalog version.
Because it's internal to the rover, do you have to also account for dust or grit? Because Mars does have occasional sandstorms, even if the air pressure is much, much lower than on Earth.
Yeah, so we're not fully exposed. So as you correctly imply in your question, we don't have to be completely sealed, but we do have covers over the rotating parts of the motor, which we could for Earth applications leave open. Here we put a cover over it and we weld it shut. Cable exits are sealed with sort of epoxy mixtures, but it's not fully hermetically sealed. It doesn't need to be.
Maxon has 10 different drives in Perseverance Rover, and this is the first time that brushless DC motors are involved. Can you describe why that's sort of a milestone? Because people may not realize that, okay, there have been certainly in other robot arms and other exploratory craft, there have been motors, but this is the first time.
Yeah, so it's the first time for Maxon that we're putting brushless motors on a Mars rover.
Mm-hmm.
Other people have done it before, and in a way, the history of Mars exploration is a bit different to maybe most other space motor missions, because historically it's nearly always brushless motors that have been used. If you go and look at things like the Voyagers or Viking landers or things like that, so it's brushless. Then when the Sojourner rover was first built, the first rover on Mars in the late 1990s, JPL was looking for a cheap way of just testing the concept of having a rover on Mars. And the problem with brushless motors is they need expensive electronic controllers, whereas a brushed motor, by definition, has brushes to do the commutation of the motor. So you just, in simple terms, you just hook up a battery to it and it turns.
Right.
You can't do that with a brushless one. And so that's a way of keeping down the costs for a simple rover. And that was what they did with Sojourner. And because that worked so well, even when they then moved on to the first science rovers, so that's Spirit and Opportunity, they decided to stick with brushed because they'd already proven the technology. And so that's why it's nearly all our motors in Spirit and Opportunity. But there is always an associated risk in that the brushes are a fairly fragile mechanical connection. And there's always sort of a wish to try and get away from them if possible. So the controller issue, I think, was really solved for Curiosity. And that's why now, also because the type of motors and the shapes that you can, or the shapes that Maxon does, were difficult to do in a brushed form for this application, and so that's why we ended up with brushless.
We've talked before about spin-off applications from the space program or benefits. Can you talk a little bit about how these brushless DC motors could have benefits in medical applications?
Yes. So in a way, it's almost the other way around, because when we first started developing Maxon's modern space motors, so this was about 10 years ago for the ExoMars mission, which was supposed to fly this year, but has been delayed for 2 years. There we discovered that a lot of Maxon's medical applications that have to be autoclavable or sterilizable were a very good starting point for the space applications. That's because the things that you need to do to a motor to make it sterilizable are generally get rid of the adhesives, because those don't like the high pressure, high temperature environment you use for sterilizing. Tend to use stainless steels rather than coated steels, and a couple of things like that. And those are the same things that you need for a low outgassing environment. So where you don't want the material, when you're in a vacuum, you don't want the materials like lots of plastics to outgas, or the adhesives that do that, and then they break down. So we had a good starting point there with the medical motors. Now we've of course done a lot of technological development over the last 10 years or so, for example, working with titanium, because we were trying to get the mass down for the flight applications. And then that was able to feed back into the medical devices when we started looking at implantable medical devices. So these are motors that get implanted in people's bodies. And that's where titanium is an ideal material, because it doesn't react with biological parts. And so there's a sort of good example of the cycle where medical helps space and space helps medical.
And speaking of biological samples, isn't that one of the goals of the Mars mission, is to search for signs of life? I mean, it's one of the most exciting possibilities or frontiers of space exploration.
That's right. So this is sort of the holy grail of Mars exploration for the last several decades, really. I mean, that was what the Viking landers in the mid to late 1970s were.
I remember.
We're trying to do that as well. And it's much more difficult than you might think is the short version of that. So certainly the goal in these samples that are being collected, amongst other things, is to look for evidence of existing or extinct life, and that puts quite a lot of requirements on the production side of these motors. Because what you don't, you're flying instrumentation to Mars that's exquisitely sensitive at detecting the signs of life.
Mm-hmm.
And what we don't want it to do is detect the signs of the Maxon employees who were assembling the motors, because they've left parts of themselves on the motor. And of course, we do that all the time. Our hands are, at an easy level, we're covered in oils, and our skin is always flaking off. And it's easy to leave all of this kind of stuff on the motor. So we have these clean rooms that we produce the motors in. The people working in there are obviously wear gloves. They also have the face masks, face masks, hair masks, sleeve, long armed sleeves, and everything that you need to minimize the amount of biological material that gets onto the motors whilst we're assembling them. And then we go for another sterilization cycle at the end where we heat the motors. But unfortunately, you can't do a full sterilization because we also have electronic components in there. And you have to find a nice balance between destroying as many microbes as possible, but not destroying your electronics.
Right. And I think that's one of the things that people may not fully realize, is that even though the vacuum and cold of space are crushing and the radiation are crushing, it is not as easy to sterilize or decontaminate, like you said, just human DNA on a microscopic level, that we don't want to think we found life on Mars and it was a stray skin cell.
Yep, that's right. That's a big risk. It's not easy to eliminate that, because life gets everywhere. I mean, we see that just looking around on Earth, even in barren deserts. If you look carefully, it's actually got quite a lot of life in it, and to completely eliminate it is difficult.
Well, and that's one of the theories I've certainly seen, is that if there is life elsewhere in the solar system, it may still have Earth-style or Terran DNA, just because asteroids might have carried stuff, or in the early stages of the formation of the system, might have carried certain materials around the system. So as much as we can, we have to eliminate at least modern life from that. That's analysis.
Right. I mean, there's these interesting Martian asteroids that have been picked up mainly in Antarctica.
Mm-hmm.
You may remember something like 20 odd years ago, there were the press releases where some research groups felt they'd found fossilized life in some of these meteorites from Antarctica, though I think mostly that's now been discounted. But that was certainly one way of looking at material that has certainly come from Mars to Earth, and logically, of course, that means that there's material from Earth that's gone to Mars, and the other way around.
Right, and if Perseverance is able to find evidence, it could be one of the biggest scientific discoveries. If we're able to really validate and verify, it could be one of the biggest discoveries of all time, certainly.
That's right, but there's a giant question really on how life on Earth evolved. I mean, I think it's clear how evolution worked from when you get from how that goes from the first multi-cell creatures through to what we have now. I think evolution explains that quite well. But how do you get from complex organic molecules to the first self-reproducing single cell animals, or whatever you want to call them, life? I think that's really a large unknown as to how unlikely that is, or how likely or unlikely that is. And finding a second place in the universe where that has happened, whether that be Mars or Enceladus or Europa and any ocean that Europa may have, that of course would really help us answer that question.
And you're doing xenopaleontology, because we know that at one time Mars is a bit more Earth-like than it is today, and that's another sort of mystery, is that how did it go from having obvious rivers and seas to being now a big rust fall.
Right.
And so I'm tremendously excited. Speaking of exploring more of Mars, I know Maxon is also contributing to, was that a helicopter that's going to be there?
That's right. So there's a helicopter strapped to the bottom of the Mars 2020 rover. There's a deployment arm on that, which uses a motor from us. Then the helicopter itself has swash plates on it, as a helicopter on Earth would, and there's 6 maxon motors that control the orientation of those swash plates, which in turn then enable you to steer the helicopter. I know the helicopter is sort of has a twin-sided view from many of the JPL people we were working with, because they've of course spent years and years working on the rover itself.
Mm-hmm.
But everyone's fully aware that the helicopter, if it works properly, is going to completely dominate the headlines. Certainly at the beginning of the mission.
Well, and it dominates the headlines because it's. I can understand the visual element or the novelty of it. I don't know that many the general audience might appreciate how difficult it is to fly on Mars versus flying on Earth. You know,
right. So the Mars atmosphere.
Flapping your wings and flying versus swimming.
Right. The Mars atmosphere is only about 1/100th of the thickness of the Earth's atmosphere. So of course you get far less lift from the rotor blades than you would do here. The only reason it works is because Mars, of course, is much smaller than the Earth, so its gravity is also a lot less. So you can just about make it work. You have to make it as light as you possibly can. You put very large, I think they're like sort of 1 meter diameter rotor blades on it, and then it will fly for a couple of minutes. I think 6 minutes or something like that is, or 5 minutes or something like that. It's the length of the flight.
And it's designed to return. Right, it's not a one-way trip.
Correct. So I think there's a minimum of, I forget the exact numbers. It's something like 6 or 7 flights that they want for mission success. So you should view the helicopter as being the modern equivalent of the Sojourner rover. So it's just an engineering test. It'll be successful if it lifts off, lands, and repeats that a couple of times.
Right.
That'll show the concepts, and then that will enable future missions where you can be more ambitious. And then start attaching science instruments to it and things like that. At the moment, I don't think it has anything other than a camera on it, but that alone will be enough. So the idea is that the rover, when it gets to a suitable spot, will deposit the helicopter on the ground. The helicopter doesn't have the same cleanliness requirements as we were just talking about for biological contamination as the rover does. So it'll put it on the ground and will drive away, and then the helicopter's never allowed to come anywhere close to the rover again.
Oh, wow. Okay.
So once they get a certain distance away, then they'll start doing their flight tests. The idea for maybe in future missions is also to carry helicopters that would enable you to look at the terrain that the rover is about to be crossing in the next sort of week or so, better than they can at the moment. Because at the moment, there's only 2 scales you can look at. There's what the rover camera can see, which is obviously only just within a few tens of meters. And there's what you can see from orbit,
which is
a long way away.
Right.
So it would be nice to have intermediate distances, what's coming up in detail over the next 1 kilometer or so that the rover's supposed to be driving, because then you wouldn't have to do quite so much sort of changing your planning midway through when you suddenly discover there's a field of rocks or something that were too small to see from orbit, but too far away to see from the rover.
And even at the speed of light, the ability to send commands from Earth means that you can't steer in real time. You can't avoid a pothole or a boulder. The robot has to be able to do that on its own.
Correct, that's right. So depending on where the Earth and Mars are on their orbits, whether they're on the same side of the sun or the opposite sides, it's between about 5 and 30 minutes, the light travel time. Then you times 2, of course, to send a command and get a response.
Obviously, this is a whole great mission on its own thing. Do you think at some point it is worth sending humans to Mars to continue this kind of exploration?
Absolutely. I mean, I would certainly subscribe to the idea that the whole point of this is to understand what Mars is like, with the aim of them being able to go there ourselves. I mean, way back in the late 1960s, I think it was assumed that that was the next logical step after Apollo. I think what they really missed out there was what's the reason for going to Mars,
Right.
because Apollo, of course, was fully funded by the government without any commercial reason for going there. There was more a sort of competition with the Russians that really enabled Apollo to happen way ahead of its time technologically. Now maybe this is becoming a little bit clearer that maybe asteroid mining and a base for doing that from might be a reason, or you've got Elon Musk's justification, which is just not put all your eggs in one basket and
Right.
Stretch humans across 2 planets.
There's the idea of space tourism eventually, and the commercialization of space, I think, is going to be essential, at least as a component, because funding these kinds of projects is a massive undertaking. But on the other hand, there also has to be the international cooperation and a little bit of healthy competition, where it's being pursued for science and bragging rights. Obviously, NASA wants to get there. We know that other countries also want to plant the flag on the red planet, and whether it's a mix of motivations and a mix of techniques, it's absolutely fascinating to pursue.
Yeah, so I would certainly hope that the reason for going there is not just to plant flags. I think most people
No.
who have the vision of that sort of move beyond the sort of national states view. I would very much hope that we manage to do that by having everybody cooperate together, because it would be obviously an enormously expensive undertaking. Elon Musk, I think, is really at the moment only looking at, so SpaceX obviously, is only really looking at the how do you travel there and
Right.
travel back again. But there's a whole mass of other technology you need to, how do you live there? How do you sustain human life on Mars for more than just a couple of weeks? There's a whole mass of other technologies there, which almost certainly beyond SpaceX by themselves.
Yeah, and I've been in contact with the X Prize folks who have had a number of competitions, and DARPA and NASA and other agencies, which are also trying to get the science there. Shifting gears for a moment, now, obviously, there's been the big news this year, the first half of this year so far, has been the COVID-19 pandemic. And how has that affected your operations? Because launch windows and the timelines have been set, have been endorsed for years, but at the same time, you're now suddenly having to work from home or collaborate long distance.
Right. So, I mean, there's a lot of interesting effects that have come out of this. I mean, firstly, Maxon itself has not been enormously affected, certainly compared to many other companies. In part because 50% of our turnover comes from medical products. And this got an enormous boost the first part of this year for lots of emergency medical orders, in particular for ventilators, which of course is the thing that everybody wants at the moment. Ventilators have motors in them, and we're one of the standard suppliers to the standard manufacturers of ventilators. We're also maybe very fortunate, certainly looking at some of the other European countries around Switzerland, in how the Swiss government handled this, which was in a very much lighter touch than you've seen in countries like Italy and Spain, where they just blanket closed everything down. So Maxon was never closed. And the Swiss government just gives out a lot of recommendations to manufacturing companies on what they should do, and Maxon carefully follows all of those. And that was to do things like divide the groups up into 2 teams, and always so no matter what group it was. So the Space Lab, for example, was divided into 2. Various other parts of Maxon were divided into 2, and you only ever have one of those teams in Maxon at a time. With the idea being, if one of those teams then got infected, you could isolate them from the other half. Mm-hmm. So that meant that all the office people are doing 50% home office. Is the short version of that. But of course, production lines have to continue running, and you can't do production from home. So we worked a lot at the beginning with because the physical distancing within the production was very difficult. So we worked at the beginning with a lot of just plastic sheets hanging everywhere. But now that's been sort of professionalized, and we have plexiglass planes everywhere between the different workstations for the people who are working there. So sheets of vertical plexiglass. And that seems to have worked pretty well. There have only been a handful of cases within Maxon worldwide, which we have manufacturing in about 5 different countries, including the US. So I think we've been lucky there on the our market hasn't collapsed side, and we've been lucky in that the headquarters here was in Switzerland and not in maybe some of the other European countries where you could say maybe the governments responded differently. And I think the positive side that I think a lot of people have noticed is this working from home actually works pretty well for a lot of people. Not everyone, because I know it always depends on your family circumstances, but for a lot of us it's worked quite well. And we're certainly of the opinion, this idea that a lot of people sort of, you get in your car in the morning, you drive an hour somewhere, you spend all day answering emails, and then you drive an hour back in the evening. makes no sense at all.
Right.
And I think that's going to be gone. I think we'll be doing less than 50% home office in the future, but I think the idea that you spend a day or two at home and not the whole time in the office for a company like Maxon makes sense, and I suspect will be retained.
Now, on a lighter note, what's your favorite robot, real or fictional? And you can't say Perseverance.
I wouldn't have said Perseverance anyway. It's got to be something like Voyager 2 for if we're talking about real ones. The what was achieved with 1970s technology there, really pushing the limit of what was possible on an absolute deadline, because the launch window for doing the Grand Tour only comes up, whatever is it, 176 years, I think. So they had to launch in the late 1970s, or the whole mission didn't work. And to still have that working now, 45 years later, is just a fantastic achievement.
Yeah, and the amount of science that it has yielded in terms of, as you said, the Grand Tour is, I remember waiting with bated breath every time I got near a planet, and it's been one of the real success stories of space exploration and achievement of humanity in general, not just one country or one agency.
That's right. And if you want a fictional one, we're doing this as a Zoom call, but without video. But if you had a video on, you'd see a Lego R2-D2 behind me. So that's got to be the best fictional robot.
There we go. Well, and R2-D2 is definitely in some ways a model for what we've seen in space exploration, where you have this one robot that has multiple attachments that can do multiple missions.
That's right. He's clearly got lots of motors in him. So
he absolutely does. Well, that caused a lot of problems back in the late 70s when they were making the early movies. Now the fans have been able to build, and even Lego builders have been able to build something that is closer to what would be useful. Well, and obviously we're all looking forward to the Perseverance actual mission. Can you give us a brief on what happens next? Obviously there's the launch and there's some time, but when can we expect to see Maxon's motors in action?
Okay, so with the proviso that I don't necessarily have all the dates in my head, I think it's February, something like that, next year that it's supposed to land. So personally, I'm not super nervous about the launch. These are the standard rockets for launching these are super reliable. There's very unlikely to be anything going wrong there. I have to admit, I am very worried about Florida and the COVID-19 outbreak that's ongoing there.
Right.
Because we do need all the people to be able to work at the Kennedy Space Center up to the last day. So there's always a slight risk there that the teams working at the Kennedy Space Center will in some way get infected and then have to stop working. So that's, I think, the biggest risk for the launch. Assuming that we get through that, then the launch will, I'm sure, go okay. I definitely will be there biting my nails during these 7 minutes of terror, because it's been demonstrated once. The Sky Crane landing system is the most amazing landing system I've ever seen implemented. Whoever made that decision to go for that for Curiosity was a very brave person. I know they had all the analysis to show that was the right way to do it, but still there was so much new in there. I don't believe there's any organization in the world that could have pulled that off the first time other than JPL. Having worked with them now for many years, my sort of childhood dream of that's the place where all this stuff occurs, and I went and visited them a couple of times when I was a teenager on their open days, is just confirmed through working with them. There's amazing people who work there. But still, there's got to be, it's not a 99% reliable landing system. I'm pretty sure of that. So there is a small risk that something could go wrong there. If that works, then I think we're in pretty good shape. We know how to build motors. JPL knows how to build spacecraft. We as an industry have built up over decades of experience how you do the development processes so that these things work properly. It's never 99%, but it's pretty likely. And then I would imagine it normally takes a couple of weeks, maybe a month or so, to check out the spacecraft when it's on the surface. And then they start driving to the first science location, and normally you'll try and do one sample fairly quickly, so you've got one in the bag. And that'll be where we see that everything really is working.
Yeah, working in the space program is a bit like being in the military. There's a few long periods of just tedium punctuated by bits of sheer terror, right? But it's exciting, and I can't wait to see and we'll be following your progress and the overall progress very closely.
Right. Yes. I mean, we're having a lot of fun doing these projects. It's interesting how Maxon, as really an industrial specialist, has now found that the way the space industry is changing and is no longer just doing customized motors. Is that there's really a niche for us here, where we can take our industrial products, modify them, and then they work great in a lot of these applications, and they're really interesting projects to work on.
And as you said, there is always that element where it feeds back to terrestrial applications that are also can benefit people, which is fantastic as well.
Yes, absolutely. I mean, the nice thing about working with the space agencies is, of course, that because they're publicly funded, they're always wanting to advertise about what they're doing, or talk about what they're doing, so the general public sees what they're getting for their money. Unfortunately, that's not the case with normal industry. So there's a lot of space industry stuff going on at the moment that you see in the press, and that are going to be groundbreaking changes, and we're involved in a lot of those, but we're muzzled by various NDAs on those.
Now, when you are able to talk about them, do keep me in mind, because I know our audience will definitely want to hear more details.
Right. Well, I mean, the one that we do have a press release out on from several years ago is the SpaceX Dragon going to the space station. So the sort of the cargo service side. And there's solar arrays on there which are turned by our motors. The grappling fixture is locked in place by one of our motors, and the navigation bay door is opened. And so every time one of those flies, it's sort of always nice to know, our work is in those.
It is exciting, and even though it may seem or will hopefully become even more routine in the near future, I'm still thrilled every time I get to meet someone or speak with someone like yourself who is involved in things that are out there. I definitely wish you and Maxon continued success, because this is really, as you said, pushing the boundaries.
Okay, yes, thank you. Thank you for showing the interest in what we're doing.
Gino, when's that Space Robotics podcast launching again?
As soon as I get a couple more astronauts and astrophysicists and roboticists on the line. And, that's certainly one thing I want to mention is that while we've had a fantastic lineup of guests so far, if any of you out there are interested or know someone who you think would be great for us to talk to, let us know, because we're always looking for interesting and innovative people in robotics to talk to.
Yeah, absolutely. Our contact information is in the show notes as well. So that's going to do it for episode 9 of the Robot Report podcast. Thanks again to Kathy Walker and Robin Phillips for joining us today. Thanks again to everybody who tuned in. New episodes of the Robot Report podcast drop every Wednesday. We're on Apple Podcasts, Google Play, SoundCloud, Spotify, YouTube, and wherever you get your podcasts. Smash that subscribe button and please leave us a rating. For Eugene Demetri, I'm Steve Crow. Have a great week, everyone. We'll talk to you again next Wednesday.